In the rapidly evolving world of artificial intelligence, generative AI models have emerged as a groundbreaking technology, captivating both tech enthusiasts and the general public. These models are reshaping how we create and interact with digital content, from text and images to audio and video. But what exactly are generative AI models, and how do they work their magic? Let's embark on a journey to unravel the mysteries of this fascinating technology. Generative AI models are a special class of machine learning algorithms designed to create new data that closely resembles their training data. Unlike traditional AI models that focus on classification or prediction tasks, generative AI models learn to understand and replicate the underlying patterns and structures of the data they're trained on. Let me tell you some of the key points about generative models. Number one, they learn without the need for labeled data, making them incredibly versatile. Number two, these models can generate entirely new content that's similar to, but not identical to, their training data. Number three, they power a wide range of AI applications, from chatbots and virtual assistants to creative tools for artists and designers. Examples of generative AI in action: ChatGPT, a conversational AI that can engage in human-like dialogue on almost any topic. Midjourney, an AI system that creates unique images from text descriptions. Adobe Firefly, a suite of generative AI tools for creative professionals capable of generating and editing images based on text prompts. How do generative models work? To understand how generative models work, let's break it down into two main phases: the training phase and the inference or usage phase. Let's look at the training phase. During this crucial stage, the model learns from vast amounts of data. Here's what happens. Number one, data ingestion. The model is fed enormous datasets. For example, language models might be trained on the entire contents of Wikipedia, countless books, and millions of web pages. Number two, pattern recognition. As the model processes this data, it begins to recognize patterns and structures. It learns not just individual elements, but how these elements relate to each other. Number three, probability distribution. The model develops an understanding of the probability distribution of the data. In simpler terms, it learns what combinations of elements are likely to occur together. Example, let's say we're training a model on images of dogs. The model will learn common features of dogs: fur, forelegs, tails, how these features typically appear together, the variety of dog breeds, and their distinctive characteristics. Now let's understand the inference usage phase. Once trained, the model can generate new content. Here's how it works. Number one, receiving. Input. The user provides a prompt or partial input. This could be a text description, a partial image, or even a sound clip, depending on the type of model. Number two, generating output. Based on its learned patterns and probabilities, the model generates new content that matches the input while maintaining coherence and relevance. Number three, iterative refinement. Many models use techniques like sampling to generate multiple options and refine the output iteratively. Example, when you ask ChatGPT, write a poem about spring, it understands the context, poem, and subject, spring, recalls patterns and language associated with poetry and spring, generates text that fits these patterns while creating something new. Why are generative models so effective? The remarkable capabilities of generative AI models stem from several key factors. Factor one, pre-training on massive datasets. Modern generative AI models are trained on unprecedented amounts of data. For instance, GPT-3 was trained on 300 billion tokens, words, and word pieces. This extensive training allows models to develop a broad understanding of the world, akin to general knowledge in humans. The diversity of training data enables models to make connections across different domains, leading to more creative and versatile outputs. Factor 2, fine-tuning. After pre-training, models can be specialized for specific tasks through fine-tuning. This process involves additional training on a smaller, task-specific dataset. Fine-tuning allows companies to create customized AI tools for specific industries or applications. Example, Anthropic's AI assistant Claude was likely fine-tuned on conversational data and specific tasks to make it more helpful and context-aware in chat interactions. Factor 3, building on previous models. Each new generation of models builds upon the knowledge and capabilities of its predecessors. This cumulative learning approach allows for rapid advancements in the field. Techniques like transfer learning enable models to apply knowledge from one domain to another, further enhancing their capabilities. Factor 4, advanced architectures. Modern generative models use sophisticated neural network architectures such as transformers, which are particularly good at understanding context and relationships in data. These architectures allow models to process information more efficiently and generate more coherent outputs. Generative AI models represent a significant leap forward in artificial intelligence by learning to understand and replicate the patterns in vast amounts of data. These models can create new content that's often indistinguishable from human-created work. From assisting in creative processes to automating complex tasks, generative AI is opening up new possibilities across various industries. As this technology continues to evolve, we can expect even more impressive applications in the future. However, it's crucial to approach these advancements with a balance of excitement and responsibility, considering both the potential benefits and ethical implications of such powerful AI systems. The world of generative AI is vast and rapidly changing, promising to reshape how we interact with technology and pushing the boundaries of what's possible in artificial intelligence. Well, that's all for now. See you in the next video. Bye.